Hi everyone. Today I'm going to go through question 3 of November 2014 paper. This question is related to the organic structures, physical properties, and the intermolecular forces. The question starts as, give a reason why alkanes are saturated hydrocarbons. The reason for alkanes to be saturated compounds, they have only single bonds between carbon atoms. Or you may say there are no multiple bonds between carbon atoms. That is another option. But you can just go with only single bonds between carbon atoms. Write down the structural formula of the functional group of alcohols. Alcohols have carboxyl group as a functional group, and the structural formula of functional group is OH. You may write as O-H as well. Both will be acceptable. The second one is preferred. You may write OH as well. 3.2.2. A tertiary alcohol that is a structural isomer of butan-1-ol. Butan-1-ol, let us write firstly what butan-1-ol is. Butan-1-ol is with 4 carbon atoms, and we have the OH group on this first carbon atom. So let me write it here, OH. And we have sufficient of hydrogen atoms, H2, 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 and this one is H3. So this is my butan-1-ol. What we are looking for? A structural isomer, which is a tertiary alcohol. To be a tertiary alcohol, let us first make it tertiary alcohol. The carbon atom, which is bonded to functional group, the OH group, must be bonded to 3 other carbon atoms. So to be a tertiary alcohol, we need such a structure. And we have 1, 2, 3, 4, in total 4 carbon atoms. I already used all those 4 carbon atoms, so we just need to add the hydrogen atoms. This is my tertiary alcohol, which is a structural isomer of butan-1-ol. Here I forget 1. This one needs 3. And that's it. This is the structural formula of tertiary alcohol. That is structural isomer of butan-1-ol. It's not asking the name, but let me just name it in case. This is 2-methyl. This is 2-methyl propan. I need space, so let me rewrite this. This one is, 2-methyl propan 2-ol. This is the name of this tertiary alcohol. It is a structural isomer of butan-1-ol. All right. And now we go to the next one. Learners investigate factors that influence the boiling point of alkanes and alcohols. In one of the investigations, they determined the boiling point of first 3 alkanes. That means they try CH4, CH3, CH3, and CH3, CH2, CH3. These are the first three alkanes. They try to determine boiling point of those three alkanes. Write down an investigative question for this investigation. An investigative question is a question sentence which refers to the relationship between independent and the dependent variables. So we need to refer to the relationship between independent and dependent variable, and the sentence must be a question sentence because it's an investigative question. So here we need to first identify what is independent variable, what is the dependent variable. Dependent variable is clear that it is the boiling point. What is independent variable? Independent variable, as we see, what do we change in experiment? We change from methane to ethane and to propane. That means we change the number of carbon atoms, you can say. We change the chain length. You can say we change the molecular mass. We change the molecular size. And all this can be mentioned as the independent variable. So that we can say what is the relationship between, now we mentioned the independent variable and dependent variable. What is the relationship between let's say molecular mass, or you can say molecular size. You may say surface area as well, and boiling point. As you see, it ends with a question mark. That is my investigative question. And the next question, fully explain why the boiling point increases from methane to propane. From methane to propane, what happens? From methane to propane, as you see, number of carbon atoms increases. That makes the molecular mass increase, as well as it increases the molecular size, the surface area. As the molecular mass and molecular size increase, that makes the intermolecular forces, which is London force, become stronger, so that it needs more energy to overcome. So let us mention this. From methane to propane, what happens? Firstly, number of carbon, or you can say molecular mass, or surface area increases. As a result, London forces, the intermolecular forces, become stronger. So that needs more energy to overcome intermolecular forces. Okay, you need to complete the sentences basically. I'm just writing shortly. That is question 3.3. When we come to the last question, 3.4, the learners find that boiling point of propan-1-ol is higher than that of propane. Explain this observation by referring to the type of intermolecular forces present in each of these compounds. Propane 1-ol is an alcohol. Let's say this is compound A, or we can just say it like that. Propan 1-ol is alcohol and forms hydrogen bond. Remember, there is an extra force here, which is London force as well. If you want, you can mention this too. But if you don't, it's not a problem. And what do we have? The propane. Propane is an alkane, and it forms London force only. Here then, hydrogen bond is stronger than London forces. That means it needs more energy to overcome. To overcome what? The hydrogen bond. Hydrogen bond. That's it. Okay, that is question 3 of November 2014. And that's enough for now. I'll see you in the next question. Thank you so much for listening. Bye-bye.